In this screencast, I'm going to show you how we can do inverse calculations based upon the normal distribution, and this will become more clear in a moment. In a previous screencast, we worked through an example of calculating the probability that a randomly distributed variable x with mean 40 and standard deviation 0.3 would be less than 39.8. We standardized this, in other words, converted it to a standard normal variable z by taking 39.8, subtracting the mean of 40 quantity divided by 0.3, and that's the same as the probability that z is less than negative 0.67. In other words, the probability that x is less than 39.8 is this region over here shaded red, and that's the same because the area underneath both of these curves is exactly 1. That's the same as asking what's the probability that z is less than negative 0.67. And when we looked this up, we looked up in a table the cumulative up to negative 0.67, and that's about 251. Now what we're going to do is we're going to kind of take the inverse of this. For example, what x value, so we're asking for the x value, not the probability, is exceeded 10% of the time. And again, we're using this randomly distributed variable with mean 40, sigma equal 0.3. We're trying to find what value is exceeded 10% of the time, which really means that 90% of the time, the probability is 90, that we are up to that value. So that's what we're trying to find. We're trying to find this value x that is exceeded only 10% of the time. The probability that x is less than some value x is the cumulative function, capital F. If you transform this into the standard normal distribution, this is asking what's the probability that z is less than some value z. And we know that that's the cumulative up to 0.90. On the standard normal graph, it's this region. And so if we can calculate z, then we can back calculate through our standardization formula to determine what x has to be. We can do this by taking the inverse of the standard normal distribution. Sometimes you'll see it here as phi to the negative 1, meaning the inverse. We're trying to find the z value having 90% of the distribution to the left of it. So the cumulative up to that z value is 0.90. So to determine what x value is exceeded 10% of the time, there's a couple ways to do this. First of all, we can look at the tables to determine the probabilities. We're trying to find phi of some value z is equal to 0.90. We can look this up in the cumulative standard normal distribution table, table 3 in your book. We're looking for the contents of the table where we see approximately 0.9. Remember, this table is showing us the cumulative up to a value of z, and we want that to be 0.9. So we just look through here, and it looks like at a z value of 1.28, the cumulative standard normal distribution is 0.9. In other words, phi of 1.28 is equal to 0.9. And what we just did is we took the phi inverse of 0.9 and said that that's equal to 1.28. The z value corresponding to this, 90% to the left, is 1.28. We can use our standardization formula, rearrange that. So if we take the standard deviation, multiply it over, and then we add mu, we get this equation, and we can calculate the x value that's exceeded 10% of the time. So this is known as inverse calculations, inverse probability distribution calculations. I wanted to quickly show you how we can do this in Excel. So over in Excel, we can use the Norm.Inv function. If you know the probability, now this is cumulative, so it's 0.9, and you know the mean of the distribution, we knew that was 40, and we know the standard deviation is 0.3. You can always type it in like this, press enter, and it's telling you 40.384. That's the x value that's exceeded 10% of the time. And that's what we got when we did those calculations by rearranging the standardization formula. By the way, if you ever want to get a value from the table, if you don't have your book, you can always just use the norm.s.inv function. And if you have a probability of, say, 0.9, then this will give you the exact z value corresponding to that probability. So we can just use norm.s.inv of probability, and that gives you the z value, which is what we got when we looked that up in table 3. So hopefully this screencast gave you a better idea of how you can calculate z values and x values corresponding to cumulative distributions.